So in this video, we're going to start to learn how we can graph exponential functions. Now, similarly to the linear graphs we did in the last series, exponential functions can be graphed using a table of values. So we're going to be practicing that with these particular graphs. Now in this first example, we're drawing the graph of y equals 3 to the power of x. So once again, I've picked values around kind of 0, -2 to 2 is like a good starting point, because this is where the sort of main interesting stuff happens for our exponential graphs. Now, what we're going to do, we're going to substitute each of these values in and come up these x values into here to get our y value out. So x being -2, this is going to give us y equals 3 to the power of -2. In the last video, we recalled that when we have negative powers, with our index laws, we can write this as 1 over 3 squared. And this is going to give you 1 over 9. So if you're a bit shaky with your index laws, you can always put this in your calculator, but we're understanding kind of why this works. So if you want a bit of a recap on the index laws, you can look at a previous video I've done on that. Now, when I change this to -1, with 3 to the power of -1, so -1 in the x, that will give us 1 over 3 to the power of 1, which will give us 1 over 3. When I put 0 in as the power, that's just going to give me 1 back. When I put 1 as the power, it's going to give me 3. And when I put 2 as the power, 3 squared gives me 9. So I have a few values that I can work with. I have my Cartesian plane here, and we're just going to assume that each unit here, each box, each grid line is just 1 unit. Now I'm going to start on these sort of easy ones before I go into the fractional ones. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here. Okay, now, when x is -1, y is a third. So that's about here. And when x is -2, y is about 1 over 9, which is like way down here. So you can see that it's starting to, the curve that I anticipated from the previous video is starting to emerge. It's something that increases rapidly in this direction. So what I'm going to do is I'm going to draw the graph, and we're going to try to draw this, if we can, with one continuous curve. And we get something that looks like this. So we can draw arrows on here to show that this is going to continue just going down. And we don't want to kind of show this fully going like this, because remember we said that there's an asymptote at the x-axis. So we still need to show it kind of being above the x-axis. So drawing an arrow here, drawing a little arrow here, I have the graph of y equals 3 to the power of x. So we're just using our table of values, plotting points, but instead of just drawing them up, connecting them with like a ruler, because this is a curve, we want to draw one continuous curve if we can. It is a little bit tricky. Your pictures won't be perfect. Mine isn't perfect by any means, but just as we're starting off, just really try to practice this skill. Now in the next one, we are drawing the graph of y equals 2 to the power of -x. So we need to be careful with our negatives here when we substitute. But for the first one, I'm going to sub in x equals -2. So I get that y equals 2 to the power of -2. Now I have a double negative in this power. So -2 is the same as saying +2. So we get 2 to the power of +2, or 2 squared. That's going to give us 4. Same thing is going to happen if we change this to -1. I'm going to get 2 to the power of +1, which just gives me 2. 2 to the power of -0 is the same as just saying 2 to the power of 0. Anything to the power of 0 always gives us 1. Now, 2 to the power of -1, if I just sub in 1 now I get this negative power. So this will give me 1 over 2 to the power of 1, which just gives you 1 over 2. And the exact same thing is going to happen. 2 to the power of negative 2 will give you 1 over 2 squared, which is going to be 1 over 4. So now that I have all of my, a few key points that I can draw in, we want to kind of include more for our exponential function. So it's nice to do 4 or 5 so you can get the kind of general shape. But I'm now going to graph this. When x equals negative 2, y equals to 4. When x equals to negative 1, y equals 2. When x equals 0, y equals 1. When x equals 1, y equals half. And when x equals 2, y equals a quarter. So I can still see I have this sort of general shape, okay? So I can just connect this up, joining up all my points as best as I can. And I have my exponential function. So I can draw an arrow to show it continues on this side. I can extend this a little bit further, drawing my arrow. And I have the graph labeling it of y equals 2 to the power of negative x. And even just comparing these two graphs, let's just look at the key features we talked about in the previous video. Here, the power is negative. So we have 2 to the power of negative x. So this is an example of exponential decay. So it starts high and it goes down. So the kind of direction is different to this one, which has just x as the power. One more thing, the base number a here is 2, so it's smaller compared to this base number of 3. So the graph here, when we have a 3 at the bottom, appears steeper than this one. This one doesn't go up as quickly. This one looks way steeper just looking at it. So this is how we can kind of graph out our exponential functions. We start with a table of values, pick 5 numbers. These are a really good start. And then find the y kind of output. Put your x in, or your x's in, get a y out. These become points on your graph, on your Cartesian plane. You plot them in, draw up the curve. Try to do it as one continuous curve and keep practicing because it is tricky to get sort of in the initial stages. But thank you so much for watching, and I'll see you next time.